Hello and welcome to this chemistry class. This is Mr. Chilola, your teacher during this holiday. I'll take you for chemistry form 4. With a topic called rate of reaction. So this is the first topic in form 4. So I intend to present it to you now so that before you return to school, you are already familiar with the topic and its contents. You are already familiar with problems or questions that are associated with this topic, so that before you return to school, you are able to answer questions based on this topic. So once again, physics is totally for free, which I teach you at the main forum. But this lesson is an additional lesson for you, which you have paid for, and it is going to be sent directly to your inbox, WhatsApp inbox. So these videos are recorded on a high definition. That means you have the option of downloading them from site, and also watch them on TV, plasma television, but you can as well watch them on a laptop, a phone that you are using, Android phone. You can also use iOS devices such as iPhone, iPad, or Android tablets. Any device that supports videos, you can actually watch them there. In case you want to order more tutorials, you can contact this number here, which you see at the bottom there. Let me, in a special way, thank Black Slides Content Masters, who are making this production easy for me. Right, these can also be contacted on the numbers shown here. In case you want to have some subject matter prepared for you in form of videos, we can actually do that for you. Otherwise, once again, my name is Mr. Chilola, your teacher during this holiday in chemistry. So this topic is topic number 1 in form 4, which is called rate of reaction. Rate of reaction. All right, rate of reaction. All right, so we'll discuss what we mean by rate. All right, rate of reaction, what it is, and what it involves. Yeah, what it involves. So by the end of the topic, you are going to define the term rate of reaction. Right, so define the topic. What is a rate? Rate of reaction, what is it? What do we mean in relation to chemical reactions? What is the rate? Do we mean by a rate of reaction? Define the term rate of reaction. You should be able to do that when you have learned this lesson. All right, we'll also look at what is called the collision theory in relation to rate of reaction. So you should be able to describe the collision theory. We shall see what this is in this lesson. Later, we are going to describe factors that affect the rate of reaction. The rate of reaction. All right, you have looked at chemical reactions before in Form 1, for example. That's where you learned about the chemical reactions for the first time, maybe, where you defined a chemical reaction as simply the rearrangement of atoms, all right, to form new products. Remember that a chemical reaction is also called a chemical change, all right? So in this topic, we're going to look at how fast do chemical reactions take place, all right? And also the factors that affect the rate of chemical reactions, how fast chemical reactions occur. All right, we are also going to consider or to look at different methods of measuring the rate of reaction. The rate of reaction is a quantity in chemistry, all right? It can be quantified. We can measure it, you can carry out an experiment to measure the rate of a chemical reaction. So we are going to look at this in this lesson or topic. All right. So let's proceed by looking at each of the objectives. So once again, we are saying after you have learned the lesson, the topic, you should be able to define the term rate of reaction and also describe the collision theory. What is collision theory? Describe, all right, like explaining it, all right, and also describe factors that affect the rate of reaction. Later, we'll look at the different methods of measuring the rate of reaction. Okay, the rate of reaction. Great. Later on, at the very end, we are going to look at the two types of reactions, chemical reactions, and relate them to the topic, rate of reaction. All right, some reactions are reversible, meaning that they go back and forth, all right, forward and backwards, okay, all right, and there are others which do not go back and forth. They are unidirectional, they go in one direction, all right, so we'll look at this and relate to the topic of rate of reaction. All right, so let's define rate of reaction, definition. All right, what do you understand by the word rate? All right, rate. For example, in physics, you have concepts like rate or speed, speed of a body. All right, you say it's the rate of change of distance with time, okay? Or velocity, you define it as the rate of change of displacement, rate. So what does rate mean? All right, rate, okay, as it relates to chemical reactions. What is it? All right, so we're going to look at the definition, all right, you can take down notes only as you learn, all right, so that you can refer to them. But if you don't take down notes, that's all right, because I'll also send you a PDF file of the same lesson so that you can read in your own time. Okay. In chemistry, we define a rate, the rate of a chemical reaction, all right, in terms of measure of how quickly a reactant is used up or how a product is formed. Okay, so we are saying the rate of a chemical reaction, what does it do? It measures how quickly a reactant is used up or how a product is formed. A very useful definition here. So in short, we are saying rate of reaction is simply the change in the amount of reactant or product per unit time. All right, so we have brought in a very important quantity here, which is time. That's why a rate of reaction or rate of anything. It means something divided by time. You're looking at the change, the change of a quantity with respect to time. So the rate of a chemical reaction, therefore, is the change in the amount of a reactant or product per unit time. All right? Okay. So what is rate? Rate is the change in the amount of reactant or product per unit time. So this change in the amount of reactant can be a decrease. Yeah. Suppose you have two substances that are reacting. Let's say you are reacting carbon. Carbon is reacting with oxygen gas, all right, to form carbon dioxide. All right. Okay. So the reactants in that case are carbon and oxygen. All right. So as the reaction progresses, what is happening to the what happens to the oxygen and the carbon? They are used up. All right. They are used up. In other words, they're decreasing. They are decreasing. Their concentrations decrease. All right. But at the same time, the amount of carbon dioxide formed is what is happening to it. It's increasing. All right. So reactant decreases, product increases. All right. So we are saying that change in the amount of time, in the amount of reactant or product per unit time is called rate of reaction. Okay. This is a very important definition. In other words, when you're looking at the rate of reaction, you are simply concerned about the speed of a reaction, how fast a reaction takes place. You have observed such reactions where you see a reaction taking place very quickly. For example, when you take you burn magnesium, okay, you find that the reaction goes very fast. Okay, so in other words, the rate of reaction for the burning of magnesium is high. Yeah, but some reactions are very slow. For example, when you look at the rusting of iron, a nail, you put a nail in water and expose it to oxygen, leave it for some days. After some time, you find that rust forms on the nail, on the iron. Such reactions are very, very slow. All right. Okay. So some reactions can be fast, others can be slow. Okay. So whichever the case, the rate of reaction is just that speed of reactants changing, the rate at which the reactants are decreasing and the products are forming. Okay, so as the reactants change in terms of concentration and amount, and the products are also forming, time is going. So you are looking at that change with respect to time. So the rate of a chemical reaction measures that change, all right, in which a reactant is being used up or the product is forming. All right, I hope you got the definition there. That's very important. You can try to put this in your own understanding, which is what we encourage all the time, that when a definition is given to you, you should be able to frame it up in your own understanding without changing the meaning. All right. So what is rate of reaction again? All right. You should be able to say. So it's simply the change in the amount. The change can be an increase or a decrease. A decrease occurs on the reactant because reactants are used up in a chemical reaction while products are forming. Great. Let's look at an example just to explain this further. Suppose you are carrying out a chemical reaction, sodium, in which sodium is reacting with the water to form sodium hydroxide and hydrogen gas. When sodium metal reacts with water, the product is sodium hydroxide and hydrogen gas. So sodium reacts with water to form sodium hydroxide and the hydrogen gas, according to the equation here. So we have an equation there in which sodium reacts with water to form sodium hydroxide and the hydrogen gas. All right. So if we go back to the definition of rate of reaction, all right. Okay, we are saying that it is the change in the products. In other words, when the sodium and the water are reacting, the amount of sodium that is added to water in the course of the reaction will decrease, all right, as time goes, all right. So the rate at which sodium is used up with time is our rate of reaction. At the same time, if sodium hydroxide is produced, in other words, the amount of sodium hydroxide increases as sodium is used up. Sodium hydroxide increases, as well as the volume of the hydrogen gas also increases. All right. So we are looking at the amount of sodium hydroxide formed per unit time. All right, per unit time, or the volume of the hydrogen gas formed per unit time. That one is going to be our rate of reaction. So in symbols, we have sodium is Na in solid state reacting with H2O water in liquid state to give sodium hydroxide. All right, this is supposed to be sodium hydroxide. Sodium hydroxide is a sodium hydroxide is a NaOH. So please take note of this. There must be an H there. Okay, so we are saying sodium metal reacts with water. What is formed is sodium hydroxide, and so to measure the rate of reaction here, we simply look at the increase in the concentration of sodium hydroxide which is formed, as well as the volume of the hydrogen gas. All right, so these changes occur with time. So the amount of sodium hydroxide formed per unit time is going to give us a rate of this reaction, as well as the volume of the hydrogen gas formed there with time will give us the rate of reaction. So we are saying the rate of this reaction is the change in the amount of sodium consumed. Sodium metal is being consumed in the reaction, it's being used up, or the change in the amount of sodium hydroxide, all right, sodium hydroxide forming there, or indeed the change in the volume of hydrogen gas formed. Okay, all right, so that's what we're saying. So to measure the rate of this reaction, we have to consider at what rate does sodium metal decrease, or at what rate does sodium hydroxide form, as well as at what rate does the volume of the hydrogen gas increase. So that gives us the rate of chemical reaction. All right, in case you are not sure about this explanation, please feel free to get back to me on the number that I provided earlier on. Great. Okay, now for a chemical reaction to occur, particles of the reactants must undergo what is called collision. All right, collision. What do you understand by collision? Collision, what's the meaning of collision? To collide, all right? It simply means what? To hit each other. Particles hitting, all right? Particles hitting, okay? So that brings us to a very useful theory, which is called the collision theory. And we're going to look at what it states and also relate it to our definition of rate of reaction, the topic. Okay, so the collision theory is just a statement. It states that for a chemical reaction to take place, for any two substances to react, think about substances that react. You think of carbon reacting with oxygen to form carbon dioxide or carbon monoxide, you know, or the example that we looked at earlier on of sodium metal reacting with water. All right, those are substances that react. Okay, and they are made up of particles, all right? So the behavior of the particles to bring about a chemical reaction is explained by what we call the collision theory. So what does it state? Okay? So a collision theory states that for a chemical reaction to take place, all right, what should happen? The reactant particles must collide with each other. Okay, how does this sound? So particles must hit each other in the first place. In the absence of such collision, a chemical reaction cannot take place. So, for example, carbon reacting with oxygen, the carbon particles must collide with the oxygen particles. Then a chemical reaction may take place. All right? So collision, to collide means hitting, particles hitting each other. In whatever environment, maybe in a beaker or in a container, whatever container, or in a test tube, the particles that are to react must collide. They must collide. Then a chemical reaction may happen, all right? I'm using the word may because not all collisions will produce a chemical reaction, okay? But also, the particles must have enough energy for the collisions to be successful, all right? So they should have enough energy content for them to react, okay? So a chemical reaction may happen, one, when particles collide with each other, and those particles should have enough energy for the collision to be successful. Okay, so what this means is that not all collisions will result into a chemical reaction. No. All right? Some particles may collide, but still no reaction takes place. Okay? No reaction takes place. There is need for what? Energy. Energy must be there for the particles to react. Yeah, to react. Okay? So not all collisions will produce a chemical reaction. Okay? Because there is need for energy. Right. So what is a successful collision? A successful collision is one that produces a chemical reaction. So not all collisions produce a chemical reaction. Some collisions do not produce a chemical reaction. I'll give you an example of if you get candle, for example, candle wax, put it on a bench, all right? In the absence of heat, the candle cannot burn, all right? Okay? Despite being surrounded by oxygen molecules which support burning, all right, you need energy. That's why you have to ignite a matchstick and then bring it closer to the candle cloth or candle wick, the wick on which burns in the candle. That one, the heat will cause successful collisions between oxygen gas around the candle and the candle molecules, the carbon and the hydrogen atoms in the candle. All right, so not all collisions will produce a chemical reaction. For a chemical reaction to happen, the collisions must be successful. So what is a successful collision? What do we mean? It's the one that produces a chemical reaction. When the particles have collided, then a reaction takes place, then such a collision is said to be a successful collision. So the more the successful collisions there are, the faster reactions. This means that as more and more particles collide with each other successfully with enough energy input, then such a reaction is going to go faster. That's what the collision theory says. All right, so the minimum amount of energy that is needed for a reaction to be successful is what is called activation energy. So this energy which is required there is called activation energy. It's the energy, the minimum energy which is required for collision to be successful. In other words, for a chemical reaction to happen. Okay, for a chemical reaction to happen, there is need for energy. The particles involved, the reactant particles involved must have a minimum energy during the collision process in order to produce a chemical reaction. So, please take note that the collision theory has 4 parts. Alright, so if they ask you to describe the collision theory, okay, it means you have to include all these parts here. So 4 marks. 1 mark goes to each point. Yeah, so the reaction particles must collide with each other. Alright, the particles must have enough energy for the collision to be successful. And the successful collision is the one that produces a chemical reaction. So the more the successful collision there are, the faster the chemical reaction. This is very important description. All right, I hope you got the description of the collision theory, because in future you'll be asked to describe the collision theory. So you have to say all these points. Great. So the explanation regarding the collision theory can be illustrated using these diagrams. Okay, so particles must collide successfully. For example, we have these 2 reactants, this one as well as this one here, and you see that they are moving towards each other. All right, they are moving towards each other. And for a chemical reaction to happen between them, they must hit each other correctly with more energy. So a chemical reaction is going to happen. But if they hit each other with little energy, even after colliding with little energy, less than the activation energy, then a chemical reaction may not happen. So we are saying, you see here, this is a head-on collision. All right, they are heading to each other. They're going to hit each other in the middle here. They're moving with more energy, and therefore a chemical reaction will take place. But if the particles are not moving in a head-on fashion, you see this one is moving its own way, this one is moving its own way. Therefore, these may not collide successfully. They will collide with less energy, and no chemical reaction may happen. All right. But also, even after the particles have collided, if they have not collided correctly, for example, if you look at molecule A colliding with molecule BC here, all right, for a chemical reaction to happen, molecule A should hit molecule B, so that we form a compound here, molecule AB. All right, so this is going to produce a chemical reaction. But if molecule A misses molecule BC, what's going to happen is no reaction is going to happen, because the arrangement of the reacting sites is not correctly achieved. So here there will be no chemical reaction. So take note of the descriptions, the illustrations. It relates back to the collision theory. So we are saying the particles must hit each other in a head-on arrangement with enough energy. Then a chemical reaction is going to happen. But if they simply collide in a glancing blow, you know, this one, if you follow it, they may hit each other slightly there. There will be no chemical reaction. But also the particles must hit the reacting sites, must hit each other in the right order, in the right orientation. Then a successful chemical reaction is going to occur. But if they don't hit each other in a correct order, then no reaction is assured. Great. Now, let's look at factors that affect the rate of a chemical reaction. For a chemical reaction to happen, we are saying that particles must collide with each other successively. All right? So the target should be the number of collisions. Particles must collide. Particles must collide. A chemical reaction will result. But if the particles don't collide, the chemical reaction is not going to happen. All right? So what are the factors that affect the rate of chemical reaction? In other words, what should happen to the reacting quantities to make sure that they successfully collide and produce a chemical reaction? Remember that a chemical reaction is as a result of successful collision of the reactants. Suppose that the molecules do not successfully collide. It means that a chemical reaction will not happen. So we are going to look at four factors. Four factors that would affect the rate of chemical reaction. Sometimes we call these factors affecting the rate of successful collisions. So a chemical reaction, the rate of a chemical reaction is affected by concentration of the reactants. In Form 3, you learned about concentration. What is concentration of a reactant? Definition of concentration is, what is it? Okay, concentration. All right, you define the concentration as simply the number of particles, which you call moles. Yeah, the number of moles, okay, of a substance per unit volume. All right, okay. In other words, simply the number of particles, okay, of the reactants. That's what it means by concentration. Yeah. Okay, how close they are to each other. All right, okay, how many particles we have in a given solution. Yeah, in simple terms. Yeah, so it can be in terms of number of moles per unit volume of solution, number of moles, number of grams, mass per volume, something like that. Okay, but anyway, here we are looking at how much of the reactants we have. All right, so sometimes you're going to have less concentration. That means fewer particles of reactants, or you can have more. That means a higher number of reactants. All right, okay. So concentration, just number of particles. Okay, how do you think this would affect the possibility of particles colliding? All right, how does it affect the possibility of a chemical reaction happening? Concentration. Okay, so the rate of a chemical reaction increases when the concentration of a reactant is increased. In other words, if you increase the number of particles of the reacting quantities, substances, the reaction will increase. But why does it increase? All right, that's what we need to explain. Why does the speed of a chemical reaction increase when we increase the number of particles of the reactants? Why? Why do you think that is the case? All right, okay, can you think about it? When suppose we increase the amount of oxygen reacting with carbon, all right, why should the reaction of carbon and oxygen increase the rate? Why should the speed of the reaction increase? Okay, all right, so you need to explain that. You as a chemist, you need to explain why the reaction, the rate of reaction increases when the concentration of the reactant is increased. All right, okay, so experiments have shown that when the concentration of a solution increases, for example, the amount of particles per unit volume also increases. Okay, so looking at the volume here of a solution, let's say you have an acid. You are looking at the reaction of acid with metals, for example. All right, so let's say you've taken a few milliliters of an acid such as hydrochloric acid added to water, and then you want to observe the reaction of the solution with metal, for example. All right, Suppose the one solution has more acid than another. Which one will produce a faster reaction? Okay, all right. Okay, so you observe that the solution, the solution of an acid which is concentrated, all right, will react more with the metal, or faster with the metal. Okay, so when the concentration of the solution increases, the amount of particles per unit volume is also going to increase. So this increases the frequency of collision. The particles are close together. You have a lot of particles, okay, in the solution, so that will increase the rate, the frequency at which the particles are colliding. So the result is increase in rate of reaction. All right, so they may ask you in an exam to explain how does concentration of reactants increase the rate of reaction. All right, so you have to say these 3 points so that you get all the 3 marks. So the rate of reaction increases when the concentration of reactant is increased. Okay, so this is because the concentration of the solution increases, the amount of particles per unit volume also increases. So this increases or leads to frequency of collision of particles. So particles will collide more and faster where the concentration is higher than where the concentration is lower. So we can show this by this diagram here. You're looking at this is a beaker in which we have fewer particles of reactants. All right, so here we have few molecules, there are few collisions. Because there are few particles, the number of collisions are also few, therefore the rate of reaction is low. All right, okay. But what happens if, suppose we increase the number of particles, like here, if you look at these green particles here, there are more here than in this beaker or container. All right, so we are going to have molecules, and therefore there are more collisions, and the rate of reaction is greater. So concentration affects the rate of reaction in that manner. So the higher the concentration, right, the faster the rate of reaction. Why does it do that? It's because of the increase in the frequency of collision of particles. That will produce the higher rate of reaction. All right, so please convince yourself that you can explain how concentration of reactants affects the rate of reaction. 3 marks. So here it's a 3 marks situation. You need to say all these 3 points in order to get full marks, explaining how concentration of reactants affects the rate of reaction. Another factor that affects rate of reaction is temperature. How do you think temperature would affect the rate of a chemical reaction? Temperature, okay? Investigations have shown that the rate of a chemical reaction increases when temperature is increased. So when temperature is raised, all right, say from 25 to 30 degrees or kelvins, all right, the rate of a reaction increases. But like I said, you should be able to explain why. Why does the rate of reaction increase when the temperature increases? Okay, all right. So you know from physics, where you learned about the kinetic theory of matter, at the higher temperatures, what happens to the particles, to the kinetic energy? So the kinetic energy of the particles increases. So at the higher temperatures, the reactant particles have more kinetic energy. All right, meaning that as temperature increases, the particles gain kinetic energy. So what does kinetic energy do? All right, it will cause the fast particles to move faster and also to collide more often. All right, so we are saying an increase in the temperature leads to increase in kinetic energy. This is the part of the kinetic theory of matter which you learned about in physics, right? So this causes the particles to move faster and more often, all right? More often, okay? So remember that a successful chemical reaction shall need particles to collide. So the frequency of the collision of particles here will lead to a successful collision. Therefore, a chemical reaction is going to be guaranteed. Okay? So once again, to explain how temperature affects the rate of reaction, you have to mention all these points in order to gain the full marks allocated to you. All right? So how does the rate of reaction increase when temperature is increased? All right? It's because of kinetic energy. The kinetic energy causes particles to move quite often, to collide quite often and faster, and this leads to a higher rate of chemical reaction. So this is a 4 marks question which will require you to state all these points when you're asked to explain how temperature affects the rate of a chemical reaction. All right? The next factor that affects the rate of chemical reaction is what we call surface area of solid reactants. Now here, notice that we are looking at the solid reactants. This surface area applies to solid reactants. Okay? For example, let's say you are burning your charcoal, you are burning charcoal. You have 2 forms of charcoal. You have powdered charcoal and powdered charcoal, and you want to burn the 2. Which one is gonna burn first? Okay, right? That's what we mean by surface area, right? So we have smaller particles in one case and bigger particles in another case. So the situation is going to be different when the 2 are reacting. Okay, we are involved in a chemical reaction. For example, suppose you want to react a substance such as calcium carbonate with large particles. You want to react it with, say, an acid, for example, sulfuric acid. Okay, and is it going to make a difference if you grind the particles of calcium carbonate in terms of which one is going to react faster? Okay, all right. So surface area of solid refers to simply the size of particles. Yeah, this is size of particles. Bigger particles or smaller particles. All right. So how does this affect the rate of chemical reaction? Investigations have shown that when the size of particles of a solid decreases, all right, like you are turning the substance into powder, let's say charcoal, for example, you are grinding it into powder, all right, that's decreasing the particle size, all right. Surface area of the solid increases. Take note of this. Many people miss this part. So the solid decreases in particle size. What is happening? The surface area of the substance as a result increases. In other words, we are looking at as many sites or parts of the substance as possible are exposed to the other reactant during a chemical reaction. So we are saying when the size of the particles of the solid decreases, surface area of that substance increases. A decrease in size, particle size, increases surface area. This surface area is the area, the outer part of the reacting substances exposed to the other reactant. That's what we mean by surface area. Okay? So this decrease in particle size and increase in surface area, all right, allows the particles to collide with each other very, very often. So the result is that the rate of chemical reaction is going to increase. Take note here. How do you decrease size of particles of a substance? By simply crushing it. All right. Let's say you are taking medicine. All right. You are taking medicine. When you take medicine, like pills or tablets which are powdered, you find that they work faster than large tablets. All right. Why? Because when you powder the pills, the tablets, you are decreasing the particle size, and also you are decreasing the surface area which is participating in the reaction in your body, which makes you get better real quick. So this is why powdered pills work faster than large tablets. So for example, you have a large tablet here. All right, if you take this tablet with water there, it may take longer to work in your body, right, than when you break it into pebbles like these ones. All right, so taking pebbles like this, okay, with water will make the medicine work faster than when you take a large pill. All right, or if you crush the tablet further, okay, these particles further, so that you drink the medicine, you take it with water in powder form. This is going to work real quickly, and you can get better very, very fast because of the surface area. So the small particles that are here have larger surface area, okay, on which the reaction in the with the substances in the body, for example in the blood plasma, will take place real faster than when you take a large tablet. All right, so what are we saying? We are saying that when you crush particles of the reactants, cut them, make them small, what are you doing? You're increasing the surface area, okay, so that will make particles to collide with each other very, very easily, and that will lead to high rate of chemical reaction. So they ask you again to explain how surface area of solid reactants speeds up a chemical reaction. You have to mention these 3 points so that you gain the 3 marks. Great. So unless you have questions, but if you have questions, you need further clarification, please don't hesitate to come back to me. The rate of a chemical reaction is also affected by what we call a catalyst. A catalyst, all right? A catalyst. What is a catalyst? All right? You learned in inorganic chemistry, in Form 3, you defined a catalyst. All right? Okay, so what is a catalyst? How do you define a catalyst? So a catalyst is simply a substance, okay, which you make this chemical reaction to take place really quickly, okay? It speeds up a chemical reaction, but itself does not change, okay? Let's say, for example, you are carrying out a chemical reaction, all right, which needs to be speeded up by a catalyst. Let's say you take 10 grams of the catalyst and add it to the reactant so that the reaction goes or proceeds quickly. All right. At the end of the reaction, you can recover the 10 grams of the catalyst because the catalyst is not used up in a chemical reaction. Okay. So any substance which speeds up a chemical reaction without itself changing is called a catalyst. Okay, so how does a catalyst lower or speed up a chemical reaction? The role of the a catalyst is simply to lower the energy which is needed for the reaction to occur. So what it does is to reduce the amount of energy needed. so that the reaction can start. All right. Some reactions need huge amounts of energy in order for them to start. All right. So using a catalyst will lower that energy which is needed so that the reaction can start. So lowering activation energy will increase the frequency of successful collisions. All right. Okay. So that the reaction can proceed. The reaction can proceed. Remember that for a reaction to happen, there must be successful collisions. So if those successful collisions are not achieved, the reaction will not happen. So what a catalyst does is to reduce, to lower the activation energy so that the chemical reaction will take place. Thank you very much. This brings us to the end of the lesson, our first lesson of rate of reaction, of the topic rate of reaction. This is the first topic in Form 4. So we've looked at the definition of rate of reaction. We have stated the collision theory. We have also looked at the 4 factors that affect the rate of a chemical reaction. But before I go, I want you to work on these questions now. All right. So the first question says, define the term rate of reaction. This should read as the term rate of reaction. All right. So we define the rate of reaction. Remember that definitions in an exam carry 1 mark. Right. They carry 1 mark. So define the term rate of reaction, which we already looked at. A chemical reaction may not take place even if the particles collide. Explain why this is the case. We also explained a lot on this one to say that not all collisions will produce a chemical reaction. Right? So what else should happen apart from colliding? Okay, so explain this. All right. State the collision theory. State the collision theory. We also looked at the collision theory. Please state it. You can state it in your own ways, the way you understand it. All right? As long as you don't turn away from the key concepts. Explain why powdered charcoal may burn faster than large lumps of charcoal. Okay? So this has to do with one of the factors affecting rate of reaction. So why would powdered charcoal burn faster? All right. So this is a 3 marks question again. You should be able to present 3 facts that support this idea. Why powdered charcoal may burn faster than large lumps of charcoal. Okay. You're also going to explain how each of the following factors affect the rate of a chemical reaction. So we have temperature here, a catalyst, surface area of solids or solid particles, concentration of reactants. Okay? All right? So explain how each one of them affects the rate of a chemical reaction. Number 6, a student investigated the rate of reaction between calcium carbonate. Okay, this is called marble in everyday language. Marble. You have read about marble, right? Marble chips. All right. So a student investigated the rate of reaction between calcium carbonate and the hydrochloric acid. All right. Explain in terms of particles and collisions the effect that increasing the surface area of calcium carbonate has on the rate of reaction. Right, this is a 3 mark question. That means you need to present 3 good facts to answer this question. Once again, thank you very much. This brings us to the end of lesson 1. In case you have questions, please don't hesitate to send us a question so that we can assist you to understand the topic and the lesson. We meet again in our next lesson tomorrow. Thank you very much. I'm expecting the solutions to the questions today, by the end of business today. All you have to do is write the questions down in your chemistry book and scan. You can either scan or just take good pictures and send to me so that I can mark and give you feedback on the same. For now, thank you very much and bye-bye.